Hello guys, in this video we're gonna continue the node voltage method, and today we're gonna explore a new concept called the supernode. Okay, so basically a supernode is basically two nodes that have like a voltage source in between, a battery in between. Okay, so as you're gonna see, there is nothing new here. It's exactly the same steps that we're gonna follow to solve any like node voltage method, or circuit before. Okay, with node voltage method, but since there is a new connection here between some of the nodes in our circuit, it might confuse you, although it is exactly the same. What we need to do is to use this super node in our advantage. Basically, we're gonna create a new equation to solve, to add to our like equations that we're gonna build out of the circuit and solve the system. Okay, so the first step is to find the nodes in the circuit. This is basically a node voltage method, and in that example here we need to find I. This is the unknown here. Okay, so if we find the voltage of that node and that node, we can like subtract them and divide by those two ohm and find I. So, and we need to solve this with the node voltage method. So the first step is to find the nodes in the circuit. We said before, the node is any like node that you have, any point that you have that have more than or equal to three branches or more than two branches. So we have this one here has more than two branches. We have four here. We have this one also. It has four branches, more than two. We have this one, and we have this one. But remember that this one and this one are basically short-circuited. They are the same one. Okay? So we have V1, we have V2, and all of this one here can be called V3. First step done. Second step, take one of the nodes that you found and assign it to the ground. We can choose any one. V1 can be ground, V2 can be ground, V3 can be ground. It doesn't matter. Of course, when you solve based on what node you choose as a ground, the voltages of the other nodes, the values of the other nodes will change, but the voltage difference which matters to us across any resistance will be the same. Okay, what we matter is the voltage difference, not the individual voltages. Okay, like V1 minus V3 or V1 minus V2 or V2 minus V3. Okay, whatever V2 is, whatever V3 is, this difference should be the same. Whatever you choose, whatever or wherever you choose your ground. Okay. Usually we use the ground as the one in the bottom. You can choose V1, you can choose V2, but usually we choose V3, which is basically at the bottom of the circuit. So we're gonna choose V3 as a ground here. Some people name the ground or make the ground like that. Some people make it like that. Both are the same. It's okay. Second step done. Okay. Where is the super node? We said that the super node is any node, is any two nodes basically, that is connected by a voltage source. Okay. So we have here V2, V1, V3, but V1 and V2 has a voltage source connecting them together. So basically, this one here is our super node. This is a super node. Okay. That's what you need to know. Otherwise, even if you don't know the definition of a super node, believe me, you can still solve this circuit, using the node voltage method. So don't worry about it. Actually, when we solve right now, we will not go back and mention this super node, anytime. because basically it is just, a notion that gives you, oh, be careful. This is a little bit different than the normal like circuit that you can solve with node voltage method. All what you need to add is another step that we're gonna do right now. So the first step that we're gonna do right now is related to this super node thing. Okay, here we have the 12-volt battery, negative here, positive here, connecting V1 to the negative and V2 to the positive. So the extra step that this super node will add to you, it's adding to you actually, it's in your advantage. You know that any battery, the voltage of any battery is the positive node minus the negative node of this battery. So basically V2 minus V1 equal to the battery voltage, which is 12. So basically this super node adds for you an equation out of nothing. So it's in your advantage. Okay? That's it. We will not, go back to this super node again. We got what we need, this equation. Then we're gonna continue our node voltage method as usual. Okay? So as usual means we pick the nodes remaining after assigning the ground and just write the equation, add this node. So let's start by V1. We're gonna assume all the currents going out of V1. So we have a current here, we have a current I, we have this one, and we have also this one. Let's call it I1 here. Okay? So let's call this I2, for example. And call this I3. So it looks like I1 plus I2 plus I3 plus I equal to 0. All of them are going out, so all of them, the summation of all of them is equal to 0. Okay. I'm gonna leave I1 for a second. Okay, we're gonna go back to it after like 1 minute or so. What is I2? I2, so this branch here has, on the left, has like a current source. So the current in this branch going like that and equal to 2 amperes. And I2 is going the opposite. So it's minus 2. Good. I3. What is I3? I3 is V1 minus V2 divided by the 10 ohms. That's good. Now what is I? I is V1 minus 0 over 2. All of that is equal to 0. Now what is I1? I1 is flowing in the voltage source. So we can't apply like V1 minus V2 over something because, we do this when you have a voltage difference over a resistance, not a battery. So what we're gonna do, we're gonna continue the journey of I1. So I1 is going to V2 in here. Okay, this is I1 here. Then it's gonna branch, right? So some will go like that, some will go like that, some will go like that. So I'm gonna continue with the naming. So let's call these guys like I4, for example, I5, and I6. So I1 is equal, I1 is going into the node, and I6, 5, and 4 going out. So what is going in equal to what is going out. So I1 is equal to I4 plus I5 plus I6. So what is I4? I4 is V2 minus 20 over 4. Remember, this is a ground here, correct? So the battery do what it does. What it does, basically, it raises the voltage of its positive, then the voltage of its negative by the battery voltage. That means that this node is larger than this, is higher than this node by 20 volt. This is 0, so this is 20. So I4 is going from V2 to 20, then divide by 4 to get the value of I4. What is I5? I5 is V2 minus 0 over 4. V2 minus 0, of course, will be V2 over 4. Plus I6. What is I6? Oh, I6 is basically, V2 minus V1 over 10. V2 minus V1 over 10. So that's what we're gonna do. We're gonna take this thing here and replace this guy by all that 3 terms. So that's the complication that the Supernode adds to you. Okay, so it gives you an equation which is something easy, but it takes a little bit of extra step to find the current flowing into the battery. So it is giving you something, taking you something, but it's so simple, nothing like complicated here. You can do both easily. So let's rewrite now the first equation by replacing I1 by its value. So we have I1 is V2. I'm gonna just simplify it. So V2 over 4 minus 20 over 4 plus V2 over 4. I'm gonna keep this like that, V2 minus V1 over 10. Then we have minus 2. The rest is, the same. Plus V1 minus V2 over 10 plus V2 over 2 equal to 0. Now what I'm gonna do something, so look at this one. This is V2 minus V1 over 10. And this is V1 minus V2 over 10, right? So we can write this one here as minus V1 minus V2 over 10, correct? Because if we multiply the minus by V1 and minus V2, it's gonna be V2 minus V1 over 10, correct? But look, this one here is this, and we have here the opposite of it. So this is minus V1 minus V2 over 10, and this is plus V1 minus V2 over 10. So this guy will go with this guy. They're gonna cancel each other. Good, 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 good. So what we end up is V2 over 4. Yeah, we can also, we have V2 over 4, V2 over 4, and V2 over 2. So V2 oh, this is here. Oh, I'm sorry. Yeah, this is V1 over 2. Sorry about that, guys. This is V1 over 2. So yeah, here is V1 over 2. I'm sorry. I'm very sorry. Simple mistake. Yeah, V1 over 2. Okay. So I'm gonna also start by V1 here. So we're gonna take this and make it in the far left, V1 over 2. Okay, I'm gonna write it like that. Then we have V2 plus V2. V2, you have 1 over 4. 1 over 4. These two terms here. And that guy was taken before. Now we lift up with this one and this one. Both are negatives. You're gonna go to the other side with positive sign. So plus 2 plus 20 over 10 over 4. I'm sorry, 20 over 4 is 5. Minus 5 in this case. So minus 5 would go there in the right hand side as positive 5. Positive 5. So plus 5. So what we end up is V1 multiplied by half plus V2 multiplied by 1/4 plus 1/4, which is 1/2 again, equal to 7. You can multiply by 2. So this is V1 plus V2 equal to 14. And this is number 2. Oh, we have in this equation two unknowns, V1 and V2. So we need two equations. We have already one, V1 plus V2 equal to 14. And remember, we have another equation, V2 minus V1 equal to 12, correct? So Of course, here the order matters. So V2 minus V1, make it minus V1 plus V2. So minus V1 plus V2 equal to 12. This is equation 1. Now, if we add them together, V1 will be cancelled. So if we add them, this guy will go with this guy. So we end up is 2V2 equal to 12 plus 14, which is 26, divided by 2. So Mr. V2 is equal to 13, my friend. 13 volts. Okay, 13 volts. Now, good. So let's take this equation here. V1 is unknown still. V2 is 13 equal to 14. So V1 is equal to 1 volt. Remember, that wasn't, the question. The question was asked about I here. So I is equal to V1 minus 0 over 2. So I equal to V1 minus 0 over 2, which is the resistance. So V1 is over 2, V1 is 1 over 2, it's half amps. Okay, guys. So that's basically the supernode thing, You don't need to be scared of it. You don't need to like get panic or something like that. It is, just adding a new equation. And because we don't know how to calculate the current inside the branch of the voltage source, we have to follow the current and find its value from the other node. That's it. That's the trick. So it's giving you an equation, a ready equation that you can use. But to build the other equation, it needs a little bit like of more work. What is this more work? Is to follow the current in the voltage source branch until it goes to the other node, and from the other node get its value. Once you get its value, you have the other equation. So simple. Okay? That's it, guys. Thank you very much for watching, and see you in another video. Bye-bye.